millimeter wave paper or 60 gigahertz paper, which year I published first time. Check my name and millimeter wave and 60 gigahertz. I don't remember myself, but long before perhaps I wrote several papers on millimeter wave and 60 gigahertz. Which year was the first paper? Perhaps I have written a book also, perhaps I don't remember. Millimeter wave, 60 gigahertz, check on the Google.
1997.
1997. Which journal?
Wireless personal communication.
Wireless personal communication. And who are the authors?
1993.
1993.
And that is published in IEEE. Overview of millimeter wave windows.
So it was perhaps sometime 1990. I'm trying to recollect my memory. Why did I ask you? Samsung wanted to start research in millimeter wave in 1990s. And they wanted to fund one in Asia, one in Europe, and one in North America. And I was telling my colleague that I just wrote one sentence. Application of 60 gigahertz and millimeter wave for future wireless communication. My secretary got very angry with me. Ramji, what are you writing? Nobody will give even a single cent to you. And it is a question of 10 million euro. Are you getting crazy? I said, this is all you have to send to Samsung president. And he was surprised I was invited to give a talk. President himself was sitting in the hall to attend my talk. And I got 10 million euro by only one substance, application of 60 gigahertz millimeter wave for wireless, future wireless communication. So it is not necessary to write 100-page essay. You can write a theme and people will give you funding, they may recognize you. And thereafter I wrote several papers. I don't remember if I have written a book also. And 60 gigahertz, why it is important? Anybody who can give a short presentation on millimeter wave? Any one of you? Short presentation on millimeter wave. I think almost everybody can talk. Millimeter wave is becoming very, very, that time nobody was thinking about millimeter wave. It is not only Samsung. Once name is spread, Nick invited me in Japan. And there also Nick president was attending himself. Then Nokia, Siemens, all companies invited me to give a talk. So at least I want to hear myself one talk from one of you. Who want to come to the stage? Give a talk on millimeter wave and its applications. Anyone?
So maybe tomorrow. Need to prepare.
Pardon? You want to give?
But not now, sir.
Not now. But I am only today only. So it has to be now and never.
I can only say one or two sentences.
No, I want to hear at least 15 minutes talk. I will definitely hear from you one or two sentences also, but anyone, you already. Millimeter wave, now I cannot say future application. When I started it was future application, now it is present application. When I was giving in Japan, in Nick company, I told you Nick president himself was taking the talk. Of course, when the president is there, the hall was crowded. Same thing in Samsung and so on. So today I want to talk on millimeter wave. You want to give? Anyone want to talk on millimeter wave? If nobody, then I will request. Also, they will.
Sir, I can give a detailed talk tomorrow.
But tomorrow I am not here.
Sir, I think first half will wait.
What I will do here?
First half is allocated.
I don't know the program. I thought today my lecture is over, now I can fly away. No. Tomorrow I have to come again.
No, sir.
No, I don't remember the program. Do you have the program here?
I think Rahul has the tomorrow is the program.
Tomorrow?
Today is the last.
Today is the last.
Your
Why is telling tomorrow I have to come?
Actually, tomorrow is tutorial, sir.
Tutorial.
Yes, sir.
But that is not my job.
Yes, sir.
What do you mean by yes, sir?
So tutorial, sir. That is all.
Okay. So tomorrow I will be free person. I think anybody should talk at least few minutes. I give you 5 minutes to look into the Google and give a talk. At least you can look my presentation or my papers. That will be enough to talk. I think millimeter wave, I don't know how many papers I have published. I don't remember in 90s and so on. Might be written a book also because I have published more than 55 books. So difficult to remember what topic when I wrote. My job is to see that everybody becomes expert on different topics, not just showing the slides. And many of you have already given good talks. I am very happy. So one of you come forward for millimeter wave. How minutes I have given? 10 minutes to think. And you also think.
So, like before going into millimeter wave, first of all we need to understand why do we need millimeter wave. The reason is because the current spectrum that we are having is fully crowded. Like the spectrum that we mainly use for our wireless communication applications are restricted to sub 6 gigahertz. Most of the scenarios are below 6 gigahertz. For example, you can take cellular systems where we use 800, 900 megahertz and then 1800, 1900 megahertz. You can take scenario of ISM band. We have two main bands that operates say for 2.4 gigahertz and 5 gigahertz. So these all applications, including Zigbee, Wi-Fi, all these applications rely on the frequency band which is lower than 6 gigahertz. Now, when every application is operating on the same frequency, the sharing of spectrum is necessary. And this sharing might give you some kind of flexibility, but it is not sufficient. Why it is not sufficient? Because as the technology is growing in case of wireless scenario, the number of devices are increasing day by day. So in order to accommodate more number of users, we need more spectrum. So we need to look beyond sub 6 gigahertz. Earlier also we have seen many publications, including Professor Ramji Prasad sir publication. These publications actually motivated us to go beyond sub 6 gigahertz and to try new bands starting from 30 gigahertz to 300 gigahertz. And sir, particularly, I just saw one paper where sir mentioned all the potential use cases from 20 gigahertz to 60 gigahertz, which was published in I think WPC, Wireless Personal Communication. So in that paper, I quickly saw some of the applications. Now come to the main topic, like how and why we can utilize this unutilized band, which start from 30 gigahertz and it can go up to 300 gigahertz. The major concern here is, like as sir mentioned in one of the slide, when we move to higher frequency, the penetration losses will be there, okay? The path loss will be much higher, and considering the dense urban scenario, this will be the worst, because even you have urban scenario, the path loss coefficient will be lesser. For example, in rural scenarios, we may have the path loss coefficient 3 or 2.5, something like that, but in urban scenarios, it may go up to 5. So the power that we are transmitting or that we are using for transmitting signal will be attenuated very quickly. Now, what we can get with this millimeter wave? The first thing that we will get is the most precious thing, bandwidth. Spectrum is the most precious thing in wireless communication along with the power that you already know. So your iPhone or Nokia 1115 both are same if they don't have battery. So power is necessary. Without power, your iPhone will be even inferior than the Nokia. So this is the concern, and spectrum is the most important thing. So with the millimeter wave, we can get much better bandwidth in order to transmit our signal. Now, when something we get, the problems will also be there. So we need to address the problem. The first problem with millimeter wave is the coverage. The coverage is very less, and you cannot actually with current setup, current transmitter and receiver technologies, will not be able to get better coverage, like the practical coverage that we need in most of the scenarios. So this is the first case. We need to actually modify the transmitter receiver design, because the current transceiver systems will not be able to operate efficiently when we increase frequency, say sub gigahertz to say 60 gigahertz. As you mentioned in one of the question, like when we have this kind of capability in just one device, the cost will be definitely higher, and the complexity will become much complicated. So we need to devise some system that can actually effectively radiate the signal operating on that particular frequency. First of all, that beyond 30 gigahertz is like before 5G, it was unutilized. So when you have something free of cost, something will be there. So the something that we need to use in order to get free thing is the complexity and the cost. So first of all, how we can increase the coverage with millimeter wave? Possible solution is you can utilize massive MIMO. With the help of massive MIMO, you can have multiple antennas, and you can actually transmit signals using the same millimeter wave frequency range by employing the digital beamforming. When you have digital beamforming, you can actually penetrate some of the objects. As you know, when the bandwidth of the signal is lesser in size, it will have difficult time to pass through that particular object. So that particular phenomena we need to overcome in order to make this millimeter wave communication operational. So first thing is, we need to consider massive MIMO scenario in order to utilize this particular wave technology. The second thing is how we can utilize this for wireless backbone. So the major requirement for millimeter wave transmission is the availability of line of sight link. So as in previous few slides, sir has shown that we are now trying to achieve this wireless broadband system and performance just near to fiber communication. So how we can achieve that? By providing setup in such a way that it can actually cover the more area. So we are not following the conventional cellular model. Instead, what we do is we put the massive MIMO transmitter at the rooftop, and suppose I want to communicate to Partha, and Partha is living near Meherpur. So what Partha will do, Partha will also have some kind of receiver or transceiver that he will be placing at the rooftop, and we will try to make the line of sight, and that particular receiver will have some connection through which we can actually create a local Wi-Fi network within your room, within your house. So this particular link from my house to Partha's house will be wireless backhaul, and whatever the Wi-Fi connectivity or wireless connectivity he wants, that can be provided even over ISM band. So by using this millimeter wave technology, we are actually providing or creating the scenarios, use cases, application where high data rate transmission is possible, but at the cost of the complexity of the hardware, at the cost of some money, and of course with the continuous upgradation in the modulation techniques like OFDM or other advancement like FBMC, we will have much better coverage and reliability of the link. So that's what I can tell about millimeter
Thank
wave.
you very much. I think it's a good summary. Very good. Let me go ahead. You said in lecture 3, 4, 5.
Sir, 4.
How many slides left?
26. 26.
26. And how many minutes we have to finish the course?
20 minutes. 20 minutes.
20 minutes. So I should speak as fast as possible in Indian style. I can finish it. Okay. So 6G IoT, AI, ML and quantum computing, that's very important. And actually if you look the slides, in 6G devices, data and services will need to be intelligently orchestrated across IoT, AI, cloud and quantum environments. What is quantum environment? Everybody nowadays is writing quantum. And one of my scholars, he talks only one quantum. It just means that any is where if you are invited quantum, please ask me to fly with you. Then you can sit down and I can give the talk on quantum for 5 hours. So why quantum is becoming so popular that young students want to talk about quantum? Any one of you? Are you interested for quantum? You also talk quantum a lot? Who can talk few minutes about quantum? Quantum mechanics in physics we have studied when I was a student of perhaps first year of engineering. Quantum mechanics, that is the only word I learned. But now it is quantum. In my lecture, I think 100 times quantum has appeared. Why quantum is so important this term itself? Any one of you can, I'm not asking you this time. Let the young people come forward. Anyone? Why quantum word is so important in technology? So significant. Perhaps you might have seen at least 100 times in my slides quantum.
I'm taking a random guess. Like as per my knowledge, I'm taking a random guess because in quantum environments we can achieve those things which are not possible in the current classical mechanics. That's why quantum becomes so important.
Any other person say few more words about quantum? Only one I am missing. I am sure he will say. But before that, I want to see if anybody else. Quantum. Give a talk on quantum. Think over it. Life is easy if you talk quantum. Then I will request to say a few words about quantum. You want a mic?
As we have learned in the lectures day before yesterday and other, that whenever we are actually talking about 6G, it's basically you do need to send large amount of data because it's related to IoT, AI, cloud, and large amount of data involves data privacy. And to provide the privacy, we need to have a different privacy and secrecy mechanism. So one of the method is your quantum cryptography.
Yeah.
Because whenever we are trying to send data, if we are in quantum state, it is very difficult to predict what the state of a particular quantum. Like quantum state means that it is difficult to predict actual state of a quantum, like because of the Pauli's exclusion principle and other things. So because it is difficult to predict, so we can exploit this behavior and we can actually send data using the different spin. So people will not be able to eavesdrop what communication is going on. And another thing is the computing, because it requires huge amount of computations also, right? Because the large data will be collected by the IoT and need to be sent to multiple applications. So we need to have a scenario where computation power should be very high. So one of the methods to have a very high computation power is your quantum-based computing, because then we'll have a high-speed computation. So that much I can think of at this point.
Thank you. So let me go ahead, as I told you last time. Then the goal is to achieve autonomous, low latency, high reliability network capable of managing trillions of IoT devices. First they were talking about millions in our slide. And now millions has turned into billions and billions have turned into trillions. And if I remember Modi ji, he talks India will very soon become third richest country in the world, and he talks about $1 trillion. I'm correct.
Yes.
Somewhere when I came to India, I was reading that India will be third richest economy of the world with trillions of dollars. That is the statement about Indian Prime Minister, and I believe it. It will happen. Supporting real-time immersive applications, delivering personalized quality of experience, QoE. You understand quality of experience, quality of services, quality of experience, quality of life. Why always they use quality? Anybody can explain to me? Quality of experience, I think. Yeah, try to explain quality of experience. Any one of you? If nobody, then Partha, are you ready?
Quality of experience is in feel like it should be the best kind of thing. I'm not exactly sure how it relates in this.
I think Neha is smiling. She will compliment you. Neha, do you want to add something? Now, it is good. 2 in 1. Quality of experience.
Sir, in case of communication, we talked about the communication quality matters because
I think now I will respect also the women. Quality of experience. Everybody is talking but few sentences. Listen now.
So in my opinion, quality of
Your opinion, just say general opinion.
So quality of experience refers to the case when the requirement is fulfilled all the time, like from the service provider or whatever the device or system we have, if it can satisfy your requirement all the time.
Very good. I think just personal joke. Long time I didn't say any joke. You know, to my memory, he is assistant professor. You deserve to be full professor. Give him. Directly should jump to full professor.
Yes.
The way he has the knowledge and command in talking, in a short notice, just I say this, and he is ready to talk without any preparation. I think you should become the full professor. Otherwise, nobody gives you, then I will start a new engineering college in India. And then I will appoint you the director of the new engineering college. So, I will wait 1 year. If you are not become professor, you will be my advisor to start an engineering college in India. And remember, he should be director. And you should be the personal assistant of the director.
Yes, sir, he is coordinator.
Coordinator, okay, sorry. Coordinator. But right hand is the more than coordinator. I have told he will be right hand of the director. He will be more powerful than you then. Because everybody will be scared of him. He will say, director Saab sent me this, ask me to do this, and everybody will listen to him. So, let's go ahead. Trillions of devices supporting real-time immersive applications and quality of experience we were talking. This lecture explores how 6G will unify these advanced technologies under one cohesive orchestration architecture. Very good sentence here later. Massive IoT management by intelligent slicing and AI. Key concepts, massive machine type communication is central to 6G. Remember, this term massive machine type communication is the focal point for 6G. Self-evolving networks will dynamically update their parameters to adapt to IoT traffic. Network slicing is there, then how AI helps. Predictive traffic shaping, slicing aware, and group-based low-cost authentication. Applications are smart agriculture, logistics, urban sensing, ambient monitoring, and many more. Edge cloud devices intelligence via federated AI. After talking so many times orchestration, I don't know how many times I have seen the slides, now defining what is the orchestration. Who can define it? Say a few words about orchestration. Already she has defined it, but based on that, can any one of you talk about 5 minutes about orchestration? Any one of you? Young boys and girls, come forward. It looks this is a very important term for 6G. And if I remember at least 10-20 times today I have read orchestration. Orchestra I know.
Just like the orchestra manages all the singers, the musicians and all.
Yeah.
This orchestration, it will manage whether in the edge computing, cloud computing and the other devices.
Very good. You want to add something?
Just few things like in orchestra we have different equipments. Here also we have the edge computing, cloud computing and devices. For example, cloud computing is much capable of processing data, whereas edge computing is comparatively lesser capable. But the best thing about edge computing is it can provide you better latency, and cloud computing can have higher latency. So it depends on the requirement and like whatever the processing capability we have at the devices. So samanjas banana hai between different entities, and that coordination required some kind of intelligence architecture, and that is what we can expect from 6C in order to have better coordination between different entities that require different things and different services.
Thank you. So, what she has written, intelligent coordination between edge, cloud and devices to manage data flow and processing, more or less all of you define like that. Features of 6G, distributed computing using edge nodes, federated learning models are trained locally and aggregated globally, no raw data leaves the device. Very interesting. AI as a service. It looks alas. She has written A capital, I capital, and by mistake one can read alas. The age for real-time decisions, examples are a smart manufacturing floor and just production real-time based on edge prediction from IoT sensors without cloud dependency. Again, quantum has come, quantum machine learning for QoE, YQML. 6G will carry ultra-heavy multimedia traffic. You can understand. Very, very heavy traffic will be there. Quality of experience depends on network adaptability to bandwidth, latency, and user emotion and context. As you saw that in the morning, he was talking about emotions and so on. The key features: first, fast convergence of AI models, high accuracy in noisy environments, real-time interference. Then architecture includes 6G Open Crowd Run, 6G make and QMLRs, dynamic network slicing for prioritized traffic, quantum. Somehow quantum is following us like anything. Quantum enhanced neural networks for traffic shaping and anomaly detection. Business impact of 6G. As I told you in the beginning itself, any technology developed, money is very important. If money is not there, then technology is useless, whatever you have created. So 6G business model, growth projection, 6G infrastructure plus test beds, lot of money, $4.83 billion. I think Trump will allow India to do business. He will take over all the business. But I think maybe India comes over 6G. How far we are?
We are like running along with the other countries.
And
We are not far.
any Indian company investing money?
Mainly the Geo
Mainly you.
and Airtel.
Airtel also. And good amount of money there. Global 6G market, it's a lot of money, $1.7 trillion by 2025. I think let's collect money ourselves and start a business for 6G. It's a good business. Societal and economic values, $8 trillion plus US dollar to global GDP from 5G, 5G plus by 2030. It is Nokia forecast. Finnish people forecast is always correct. Finland people, if they say something, a small country, but maybe 100 times better than India. 6G expected, it will surprise me. Such a small company, and I don't remember about 1G, 2G, how much work they did. From 3G onwards, they are the world leader. Just they forgot to make it happen, and Nokia played a key role in the world map. We should start company here. Such a big company. We have the biggest market ourselves. We don't have to depend on anywhere else. So we should start. What do you think? Let us discuss to start a company in India. And if seriously you start, I am sure many investors will invest money. Sweden is expected to contribute massive job creation. Of course, once you have the industry and the demand, it says 69,000 new jobs in Romania from 5 years plus now. 69,000, a small country like Romania, not very rich country. It is East European country like, if you talk about Denmark or Germany or France, they are very rich compared. Romania is just like a country like India. I don't find it better than India, Romania. And then they are creating 69,000 jobs. CO2 reduction by smart grids and intelligent device management, workforce impact, rise in field and nomadic growth empowered by mobile connectivity and edge intelligence, new categories like data, AI, quantum, all will be required. So all of you will have job anywhere in the world. There will be shortage of manpower everywhere in the world, including Romania. Industry transformations, sector and transforming capacity, smart logistics, real-time tracking, swarm routing, dynamic reallocation, autonomous vehicles, some millisecond delay, 3D positioning, real-time updates, digital healthcare, then smart energy. These sectors rely on 6G's orchestration layer to handle the complexity of scale, latency, and intelligence. So I'm sure every one of you have very good job within India itself. And I don't know, India also we are getting good salary now. Comparatively, if I think of my days, very good salary. So, key takeaway, it looks I'm coming to end.
One more lecture after this.
Oh, one more lectures. How many slides?
Less than 20.
Less than 20. I will go fast. Massive IoT will require intelligent, predictive, and adaptive control. Federated AI and edge computing reduce dependence on centralized clouds. Quantum, there is no slide where quantum words didn't appear. Quantum. The business impact is profound, economically, environmentally, and socially. So intelligence plus automation plus experience is 6D orchestration. All of you are very intelligent. Automation you understand. You have already 3D, 4D experience. So we are going to 6D development. Lesson 4. This is the last lesson. And about 20 slides.
Less than 20.
Less than 20. 6G, again quantum word, even in the slide name. So 6G quantum technologies, 6G data privacy and ethics, future scope and challenge. Ethics is very important part of the development of technology. Ethics must be maintained. Human-centric challenges in CD. So human are, because they are the persons who will use the technology. So this is a good topic. 6G promises unprecedented levels of intelligence, connectivity, and integration of cyber physical systems. But as these capabilities expand, so do ethical and privacy challenges. More and more it moves. Ethics is very important. This is of course policy. Today's focus role of UAV labs in aerial infrastructure, the privacy and ethical implications of emotion-aware, immersive and biometric-driven communication, future challenges as quantum technology and AI advance. Area infrastructure sharing platforms and deployment. I don't think I should go in detail. Let me say the last point. Deployment use cases, hot spots, rural areas and disaster zones, shared infrastructure like in RAN nodes and spectrum by area and so on. Again, it looks 3 slides. Terrestrial and non-terrestrial network integration. Yeah, this is the most important. Hybrid parameter is very important. Benefits global connectivity, seamless and user experience from urban centers to oceans, ubiquitous backhauls, satellite-supported IoT aggregation, drone to cloud streaming. Architecture model, transparent payload, satellite as repeater. That is the payload we will need. Regenerative payload satellite as 6G point. Then this diagram is very interesting, and I think it's clear in itself. And you can look at in the book also, it is figure 10.5. Ravage in 6G scope and threats. Anything you do, good evening, sir. I didn't believe you will come. This fellow who is never here, but you are the magic power. He came and he is here. So he should have been here the whole lecture. Then he should have been here. And then he will talk, give the talk in 4 minutes. So I will read the title of each slide. Privacy is Sindhi. I think already I have talked a lot. Emotion, that also very important point. Regulatory, it is very important. Without regulation and policy, nothing can go. Secure slicing of resource per user application. This we have already discussed. That future scope, yeah, this we should see. The future scope and societal impact. Enablers, zero trust architecture, Edge AI, digital twins, societal shifts in hyperconnectivity in education, healthcare and governance, need for ethical by design framework and human oversight. Takeaway for day 4. I think enough thing you have learned today. That is your takeaway. Course wrap up. Advanced foundations, and this is the title of the course. Day 1. Already I have told you what takeaway was there for day 1. Title was Foundation in Emerging Use Cases. Day 2. This title was there and already I have discussed. Repeats on the slide. Day 3. Day 4. And finally, course takeaway. Are you satisfied with the course? If you are satisfied, then course takeaway is over. Done. Thank you very much. So, how many minutes we had?
5 minutes.
No, 4 minutes. Now,
I think we have been able to cover most of the things in what 6. Most of the, so I'm coming to that. So the Gyan course on 6G networks, where we were able to cover the evolution, we were able to cover some of the technology foundations from connaissance, which is Sir's favorite topic, to the roadmap to the future, 6G IoT, AI, ML, quantum orchestration. So we've been able to cover a good amount. Further, I think in yesterday's class we probably did some tutorial on how to use this 5G test box, if I may put it in this way. Then we also were able to do some practice using the drones, using your 5G new radio band. Tomorrow we'll have a demonstration of what has been depicted in yesterday's class. We'll have a hands-on experience of how a 5G test bed actually works. So, and overall, if I may put it, so it was very enjoyable. The 4 days, if I may include tomorrow also, so it has been a memorable, enjoyable experience, not only for me, but I feel for everybody over here. You've made this course something which is easy for us to sublime, for us to take in, a good takeaway, overall takeaway, if I may put it. So I think everybody must have learned something. And overall, the most important thing, since you are, we say from the communication or the wireless communication, you are one of the fathers. So we have been able to meet you in person. So that's a personal experience or an enrichment which I was probably thinking for a very long time to have association with you, right from my own PhD days. So it's a dream come true for me also, as well as for everybody over here. So so that's my takeaway, if I may put it. But thank you for accepting our invitation. Thank you for coming here, and thank you for enlightening everybody over here. Thank you so much.
I thought I